has been prepared very recently, because we had to change speakers since I cancelled yesterday. So this talk is by Jan-Piet Mens. The next talk up at 11:45 is by Bill Cheswick in this same room, Rethinking Passwords. So that is the most recent room schedule. Then about centralized logging. I became interested in this also because I'm an application administrator at a bank, which means that I don't have root rights at my work, which is very strange because I'm a Linux specialist, right? Anyway, I need to have centralized logging at my work to make things easier, and I'm trying to learn a lot of things about it. I know colleagues who are doing this, who are even in this room, and I know Jan-Piet Mens is a specialist in this. So I asked him to tell about his experiences with Greylog 2 and Logstash. So I give the word to Jan-Piet Mens.
Thank you. Good morning. There was a different picture there. Sorry. So my name is Jan-Piet, or JP. It's very embarrassing for me to speak in front of you because I am Dutch. I can even show you my passport if you want, but I don't speak Dutch. It's one of those things. I'm a consultant. I'm a bit of an architect. I'm a small-time fiddler. I do lots of things with DNS. I love LDAP. I love plain text and stuff that just works. By the way, this afternoon, apropos stuff that just works and nice things, this afternoon I'll be talking about MQTT. You must come and listen to that. I think you'll like that. So let's talk a bit about logging. Who does centralized logging already? Oh, quite a bit, quite a few. Who does logstash? Greylog? Something else? Splunk? Anybody use Splunk? You have too much money. Or too few logs. So, logs. When I say logs, I mean things like log files. I mean logs that are produced by syslog. Syslog is actually a marvelous thing, but it was very badly designed because there's no such thing as syslog standard. But when I say syslog, I mean what we typically do with syslog-D, syslog-NG, rsyslog, and all the other families of that, where we distribute log entries via typically UDP port 514. If you're good, you do TCP 514, and then you can do things like SSL and stuff like that. So we're going to discuss taking information, log entries that occur in a number of programs. Can you hear me? That occur from a number of programs that are issued. We're talking about Apache logs, for example, or Nginx logs, which are typically stored in files. Neither Apache nor Nginx, at least Nginx not in the open source version, have the possibility of using syslog. We're talking about Java stack traces that occur from your Tomcats, etc. We're talking about application logs. If you are a developer, hopefully you log, I am here, I'm now doing this, I'm going to crash, I crashed because. If you're not a developer and you're a system administrator, please tell your developers to create log entries, decent log entries, and not store them in some old file, but use some sort of standard mechanism. Now, most of us as system administrators, we have the odd Unix Linux machine. We do logging. We keep our logs in files, var log messages, var log debug log, var log this, var log that, var log Apache, etc. And what happens is these files grow tremendously large. These files have to be rotated. You need some sort of special magic to do log rotation. There are all sorts of different possibilities of doing that. You want compression, disks fill up, all sorts of stuff that goes wrong with logs. And you probably know that at least as well as I do. Now, if you're managing just a handful of machines, that's fine. What you do in the case of trouble, in case you want to find what the cause of the issue is, you log onto a machine, go to var log, and start unzipping and grepping through your logs. Right? Anybody done that? Almost everybody. Right. If you have 1,000 or 10,000 machines, or if you call Google and you have a few more than 10,000 machines, that becomes completely unhandleable. It's just completely impossible. What some of us then do is we start rsynching those logs to a central location. And then what we've actually done is just moved the problem from distributed machines onto a central machine. We still have things like file systems. We still have compressed files. We have to grep. It is almost completely impossible to correlate information, etc. So what we would very much like is a simple system, a reliable system that is able to capture logs from a whole bunch of machines, from a whole bunch of different applications, different input files, and bring them together in such a way that somebody can view, can quickly search through those logs and try and find information, and also gather statistics. How many HTTP code 500 have your web servers produced today? If there were 100 yesterday, that's fine. But if there are 10,000 today, then something's going wrong. You would perhaps like to alert to the fact that your web servers are all producing HTTP code 500. Okay? You might like to alert to the fact that your mail servers, which were maybe sending out or receiving a few thousand mails yesterday or in the course of the last month, suddenly have a peak. Peaks are bad, usually or typically bad. Peaks mean you have a problem. You might have spam, you might have viruses, etc., etc., etc. Centralized logging can help you find that information. Decentral logging, putting your logs in var log, something or other, keeping them on the machines, throwing them away periodically is not going to help you find that kind of problem. Another thing that we have to cater for are timestamps. And timestamps, if you've never thought about it, timestamps are a problem. If you look at these three log messages, I think they're a bit older, but everybody recognize these three individual lines, okay? It's all one long line. Everybody recognize it? What's the top one? Yeah, Apache access log. What's the center one? I beg your pardon? A bind zone transfer. Okay? A bind zone transfer. Here, transfer of subdomain, transfer completed, one message, so and so many bytes. And the last one? Yeah, Open LDAP, slapd, no? The slapd process with the connection request. Okay. So three completely different lines. These three completely different lines, if we look at them, you've just proven it, we look at them, we recognize them. We recognize them because there's certain things. Here we have an IP address, we have a date or timestamp in square brackets. We have the HTTP request, get, post, put, delete, etc. So we recognize that's Apache. Here we quickly recognize, okay, it's slapd, it must be Open LDAP, can't really be anything else. But that is very, very difficult to process electrically or electronically. The other thing we notice here is completely different timestamps, timestamp formats. Here we have day, month in text, year, colon, hour. Here we have a different form, day, dash, month, dash, year, blank. And here again, we have a completely different format. This is a syslog, typical syslog format. You have a month and the day, timestamp, but no year. Okay? This has to be handled somehow. And there are a whole bunch of different timestamps under the format of what time is it. Everybody know all of these? You might have seen lots of them. This here is a TAI timestamp from DJB DNS, for example. Daniel Bernstein likes those. Here we have milliseconds, okay, with a comma. So this must have been taken from perhaps a German system, decimal comma. Here we suddenly have a day of week, comma, and then the date. Yeah, this is really a gigantic pain. So when you're trying to, excuse me, correlate information, what happened, you want to be able to also correlate time. So we need some sort of system that is able to bring this information together. We are experiencing a lot of HTTP 500 error codes on our status codes on our Apache servers. And funnily enough, simultaneously, we're experiencing a lot of zone transfers. Yeah, so there may be something that correlates, but we can only correlate that if we have some form of converting the time into something that we can actually process mechanically or electrically. So the tools that I would like to introduce to you basically are logstash, Graylog2, and elasticsearch. And of course there are a lot more tools. Now it's really easy. I drew this literally on a block when a couple of years ago I started learning about logstash and Graylog, because it's pretty complicated. Now, it basically is relatively easy if you start at the bottom. Elasticsearch is a document-oriented database system which scales massively horizontally. You just add new machines, and Elasticsearch sort of does everything magically and automatically, literally magically and automatically, and it starts sharding out, it distributes, it replicates. You can take individual systems up and down. It will automatically re-synchronize them. A very, very powerful piece of software written in Java. It comes as a single jar file, and this jar file, basically you launch, it has a little configuration file, but there's nothing much to set up. So Elasticsearch is the basis, the storage basis for the two other tools that we're going to talk about. First is logstash, and the second is Graylog2. Now, here's logstash, and here's Graylog2. You can use these together, and you can also use them independently. So possible combinations are logstash plus Elasticsearch. Another combination is Graylog2 plus Elasticsearch. And a third combination is logstash plus logstash plus Graylog and Elasticsearch. Depends a little bit on what you want to do and how you want to do it. Logstash is written in Ruby, but it's JRuby. Jordan Cecil, who's the original implementer of logstash, wanted to save us a lot of work, which he thankfully did by putting all this stuff in JRuby. So what we get with logstash is, here again, a single Java jar file, and you just launch it. And this jar file wants a configuration, and in this configuration we specify inputs, filters, and outputs. An input is, where should logstash get its log entries from? How should it obtain log entries? Filters can change, can modify these log entries on the fly. For example, we can normalize timestamps. For example, we can discard particular log messages. So we're pumping everything into logstash, but we know that we don't want firewall rules coming from our Cisco routers. So we want to drop those. We can do that in logstash filters. And outputs define for logstash, where do the messages that we have filtered, if we filtered them, where do the messages that we have input, that we have filtered, where should they go to? One possibility is Elasticsearch, but there are a large number of different filters. You can tweet your messages if you want. You can send them out via XMPP. You can send them out via IRC, also different output files, etc., etc., etc. We'll look at a few examples in a moment. So here's our typical logstash configuration file, very, very short one, very simple one. we see 3 blocks: input, filters, and output. And if we look at these blocks, we have an input consisting of a file input, and there can be different inputs. We have a file input, we give it a type, and this means that all records that are read from this path, var log Apache log, will be associated with this type called Apache. It's a sort of internal field that logstash will now apply to each of the records it reads, each of the lines it reads from this file. It's very good to associate a type with an input, because this type we'll use in a moment to differentiate how we filter things. So here we have a file input, we could have a syslog input, we could have a TCP input, we could have an input from AMQP, we could have an input from XMPP, from mail, etc. Okay, different inputs. So anything that comes in from here is associated with the type Apache, and then processing carries on through an optional filter block. And in this filter block, we again have different filters that we apply. One of the filters, one of the most powerful filters, is grok. Think of grok as a grep, as an intelligent grep. And this filter, this grok filter, will only apply to messages of type Apache. Recall, please, we set the type on the input. If we had a different or a second input with a different type, those messages would not be filtered through this grok filter, because the type does not match. Now, if you look at a, I'll go back for a second. If you look at an Apache log entry, the top line, we know that there are different fields. And what we want to ideally have is have these fields separated out. And what grok separated out with an IP address, a timestamp, the HTTP verb, get, put, delete, etc., the actual URI, the HTTP version, HTTP status code, what's this? The size, username. No, it's not true. There's the username. And the client. What's the dash at the end? The referrer. Thank you. And what? Come on. I'm too far away. What grok does is to apply these patterns, and a whole bunch of patterns that are provided with logstash and with grok. We can add additional patterns. And these are regular expressions that Jordan Cecil and other people have packaged into us. So there's a regular expression called combined Apache log, and this regular expression, this magical token, will split up the default or standard Apache combined Apache log line into individual fields. And these fields are then translated or transformed into a JSON document. JSON? You know JSON, no? Okay. And this JSON document then continues, there's no more filtering we do here, continues into the output. And this output has an output of elasticsearch on host, localhost. And please note, there is no type here. So anything that comes down to this area will be written to Elasticsearch and will actually be stored. So what's happening is we're reading log files, in this case Apache logs. We're doing something, we're splitting up the fields, and then we're copying everything into Elasticsearch. That's all. I mean, it's already a lot, but that's all that logstash actually does. Reads input, does something with it optionally, and writes it out, stores it. Any questions so far? Possibly, yes. What's the change? Okay, thank you. That is very possible. I'll fix it, and you'll get the revised version. And I apologize if that's the case. I'm sorry. Yeah, when you download logstash, the documentation is quite good. It's not excellent, but it's quite good, and it's basically trivial to get started. Yeah? Basically trivial. So let's have a look at some of the inputs. This is an older list. There are a number of additional inputs, but whether they're interesting to you is a different thing. So we have, for example, AMQP out of the AMQP message queue. We have exec. Logstash can execute programs for us, sort of pipe something in. We have file that we just saw. Gelf, to talk about it a little bit later. There's a generator. If you want to, for example, create load, Logstash has a generator input, which will just generate messages, pseudo messages for you. IRC, pipe, log4j, that's out of Java things. Redis, standard in, syslog, of course. TCP, if you want to just put in a TCP stream where you can send either text messages or JSON messages. Twitter is, of course, useless for anything that is enterprise, but anyway. UDP, 0MQ, quite interesting. Okay, so a large number of inputs, and every Logstash, so far, every Logstash version has brought new inputs. So it's worth keeping up to date there. Probably the most interesting for us, at least when we start, is, and it's also my recommendation, is start with syslog. You have a machine, you're going to install Logstash, and then you take a second machine and configure syslog in such a way that it directs to your Logstash box, and that's a good way to get started looking at how Logstash operates. Then there are a number of filters. There's a date filter, the DNS filter, where you can do reverse lookups on IP addresses. Careful with that, because that will slow everything down quite a bit. Gelfify we'll look at later. The GeoIP filter uses the MaxMind database. You can associate IPv4 addresses with a country code. Okay, nice, for example, for creating graphs or lists of where does incoming email come from, or where do my incoming HTTP requests come from. grep is useful for filtering out individual messages. Groq we just saw for splitting lines into regular expression into individual fields. The JSON filter, you can remove stuff. Multi-line, very useful for example, Java stack traces. Java stack trace is always a whole bunch of lines. The multi-line is able to gather those lines up into a single log entry, which is actually what we want, otherwise the stack trace isn't readable. Yeah, XML if you must. 0MQ is a filter that allows Logstash to delegate processing of log entry to an external program. And Logstash output. We have, of course, Elasticsearch. We have as output AMQP. We have file as output. You might want to collect Cisco logs, for example, pass them through Logstash, store them in Elasticsearch, but also, in addition, store them in a file. That is possible. Yeah? MongoDB, which I wouldn't recommend, but anyway. Now you can send them out via HTTP post, via IRC, via XMPP, via WebSocket, TCP, a whole large number of log outputs. So, and this is basically how Groq, as I say, one of the most interesting filters, in my opinion, because we are able to actually parse and process our logs into individual fields, which we will later find in Elasticsearch. It's basically, you have your input, you have your Groq filter, and your output. And this filter, do types match? Yes, okay, then do that. Do types and tags match? Yes, then do Groq. And then in the filters, we can do types and tags match? Yes, mutate. Mutate means, for example, changing fields, removing fields, etc. And then in the output area, we can check do types and tags match, do that output, else do that output, etc. And if nothing matches, then just drop the log, just throw it away. So a very efficient and versatile method of parsing and grabbing at log information. Logstash needs, by the way, just the same as Graylog2, Logstash needs data. If you have syslog, for example, which is sending out to Logstash via TCP or via UDP port 514, those logs, entries are going to go there. But what happens when you restart your Logstash server? During the moment when the Logstash server is deaf, you are losing your logs. Some environments say, well, it doesn't matter. We don't really care. Okay? Other environments say, for us, it's very, very important. We must absolutely make sure that we don't lose anything. So to not lose anything, you must have some sort of a buffer. And these buffers are, for example, Redis or AMQP. Redis as a memory store or AMQP as a messaging queue would take the logs from syslog and then hand them over to Logstash as soon as Logstash is running. Of course, this means that you probably need quite a bit of resources to actually hold that information while Logstash is down. Okay? Every time you reconfigure Logstash, you must restart it. So there is a potential for losing logging information, and Redis or AMQP, for example, are two possibilities of ensuring that that doesn't happen. So Elasticsearch, as I mentioned, is the actual document database. It's based on the Lucene search engine. It's schema-free, so you can excuse me, you can write JSON documents into Elasticsearch, and Elasticsearch stores these documents in shards. You define, as system administrators, when you set up Logstash and Elasticsearch, you define how many shards you will have per server. You define how many servers, you define where they are. Do be careful, please. Elasticsearch out of the box comes configured as find my other Elasticsearches via IP multicast. My recommendation in any case is to disable that and switch to IP unicast. I was just talking to somebody who said, when I boot Elasticsearch, I see data filling up even though it's not me. Yeah, that is possible because Elasticsearch is sniffing around looking for other Elasticsearches, and if the index names match, which by default is Elasticsearch, then they start replicating. Okay, so configure IP unicast and specify the names of your Elasticsearch cluster of the individual machines in your Elasticsearch cluster, and that way nothing magical will happen, but you actually know where what is. Elasticsearch scales horizontally. You can at any moment add new boxes, add new machines, add more storage, and Elasticsearch will start replicating as per your instructions, will start replicating documents, and in other words, keeping replicas on different machines, sharding onto different machines to balance out storage, to balance out for redundancy purposes. And the whole Elasticsearch cluster, whether it's 1, 2, or many, many machines, always have a status. Green is the whole cluster is okay and operational. Yellow means the cluster is available, but something's missing. And red means cluster is degraded, something really tragic happened. For example, broken index, and you only have one machine. Be very careful, please, when you use Logstash with Elasticsearch. There are version dependencies. On the Logstash documentation, when you download Logstash, it says use Elasticsearch version so-and-so. Use exactly that version. The same on a Graylog download. It says if you install Graylog 2, you must use Elasticsearch with this version. Okay. And then comes the third portion, and that is Kibana. The Kibana is a set of JavaScript files which run in your browser. So your web browser must have access to port 9200, well, by default, TCP port 9200 of your Elasticsearch machine. And this JavaScript in your web browser contacts Elasticsearch and grabs documents. And Kibana is a wonderful tool. These are just this is just a screenshot or two that is coming up now, which shows sort of a default. You have at the top here, you have dates that you can select. Here you have a search bar. You can select full text search, or you can search for individual fields. For example, status code :500. You're looking only for status code 500 codes. Then you have a graph area, which by default is a bar graph or a line graph, which shows how many documents pertaining to this search were found over the particular time frame. These you can fold down, you can throw them away, you can drag this graph area away if you want. And here at the bottom, you have individual log entries pertaining to your search and pertaining to the time scale. And these log entries with timestamp, etc., source, the verb, these log entries have these fields associated with them. And you can then use these fields to search for other entries. You can add additional panels, you can add additional panels. You can basically reconfigure the whole look and feel of Kibana on a per search basis. If you've, for example, used the GeoIP plugin in logstash to reverse encode country codes into your IP addresses, you could create a nice looking map of the world showing where the individual data comes from. Kibana is very, very nice. It's, as I say, it's JavaScript, so it runs in the browser, and it needs direct access to Elasticsearch. And this is also a little bit of a problem. It's not a problem, but it's something you need to consider. If you want, for example, your manager to be able to run Kibana, he or she needs access to Elasticsearch port 9200. And that means that any data contained in Elasticsearch, in one of the indices that Kibana is going to access, will be visualizable by Kibana. Okay, so anything contained in Elasticsearch, your manager will be able to see, which is maybe not what you want to have, what you want to make possible. Very nice. One of the features of Kibana, which for me is very important, you can switch from black to white. But this is default, that's why I showed the default. There's a few bugs or a few hiccups in Kibana. If you switch to white, it sometimes switches back to black without anybody really knowing why. Yeah, so really very powerful, and particularly you see literally live in more or less in real time, what is coming back, what log entries are coming in, etc. How am I for time? 15? 1-5. Okay.
A quick question.
Yes.
Is this aggregated over multiple machines? Can it aggregate? So if you have a load balancer with multiple machines behind that those logs are then aggregated into one view?
Yes, but not in Kibana. What you would then do is you have those multiple machines, and they are logging, for example, to syslog or to files. Those files you bring into logstash. Logstash is now splitting them out into Elasticsearch, and then Kibana will see that. Does that answer your question? Yeah. So you cannot, at least not to my knowledge, you cannot access from Kibana multiple Elasticsearch instances. That's not designed to be so. Centralized logging means centralized. So you have one big container with all your logs, and that's what Kibana accesses. The next combination, very, very interesting, is Graylog2. This is a little bit, this is actually quite an old diagram, but most of the principles still apply. Graylog2 server and Graylog2 web interface. Two different components, both written in Java. So you have two jar files that you download and install. Greylog2 server is the beast that actually gets the logs, for example, from syslog, from files, from TCP inputs, or from logstash, if you like. So one of these things could be a logstash that is writing into Greylog. For example, you might like to do that because of the very, very strong filtering capabilities that logstash offers us, okay? If you do not require, you think you do not require those filtering capabilities, then you could have servers emitting, for example, syslog, port 514, directly into Greylog2 server. Greylog2 server then stores that data in Elasticsearch. Okay? Unfortunately, at least in my opinion, unfortunately, Greylog2 at the moment, Greylog2 server at the moment, requires MongoDB for statistics, for user authorization, stuff like that. That will, in the future, probably in relatively near future, that will disappear and will probably be replaced, I would have hoped, by Elasticsearch, but anyway, will probably be replaced by, for example, MySQL or PostgreSQL, because most enterprises have that anyway. The web interface is the second component of Greylog2, and this becomes very interesting. The web interface uses the MongoDB for authorization and accesses the Greylog2 server to actually get the data from Elasticsearch. Now, this sounds a bit convoluted. Why does the web interface not access Elasticsearch directly? The reason is Greylog2 server offers a REST API. And this REST API allows you, me, and also the Greylog2 web interface to actually access the data. But, and this is a huge difference to the way Kibana plus Elasticsearch work, due to the fact that the web interface uses the Greylog2 server API, it is automatically forced through the authorization level. So, for example, I can give a manager access rights to see particular streams of data that are coming into Greylog2 server. Whether that manager uses the web interface or whether that manager uses the REST API with curl, for example, is always forced through that authorization interface. There's no way to get around it. Yeah? So that is, my opinion, particularly interesting. Also, Greylog2 has a few more, let's say, enterprise suitable capabilities. As I said, authentication, for example, with by user ID and password, or via LDAP. There's an LDAP connector with which you can connect to your LDAP directory server to give users access to particular things. Greylog2 has also a number of inputs. One of them is syslog. The other is you can configure syslog TCP, you can configure syslog UDP, you can configure TCP in, HTTP in, you could specify the ports, and you do that not in some sort of hidden configuration file, you can do that through the web interface. So it's really very, very attractive. There's also a component called Greylog2 Radio, and Greylog2 Radio, that's an optional component. Greylog2 Radio is like a load balancer for Greylog. So you have one radio and several Greylog2 servers behind it. And Greylog2 supports something called GELF, which stands for Greylog Extended Logging Format, which is a JSON stream which contains individual fields that you want logged and can also be compressed. So there are a number of utilities, libraries, etc., which are able to produce GELF. For example, we saw earlier, Logstash has a GELF output, which is also suitable for Greylog2. Yeah? So let's have a look at the interface. The interface used to be very pink. That has changed in recent versions. At the moment, it's 0.20.2, I think. You have the date and time range where you can specify what you're looking for, over what time frame you're looking for. And you have a free text input field, but you can also search for individual fields. So for example, we're looking for the word get, and log source is example.org, and controller is login controller. Okay? You hit enter or press on the little green thing, and then the web interface gives that to Greylog2 server. Greylog2 server starts searching in Elasticsearch. and the result comes back. And here we found 10,000 messages in how much? In 46 milliseconds. So it's really pretty fast. Not to say gigantically fast. On my Mac there, on my laptop, I'm able to pump with GELF, compressed GELF, so in other words, it's quite a bit of zip, unzip handling. I'm able to pump about 12,000 messages per second into Graylog2 server. Okay, so it's really pretty fast. At a client site where I'm deploying Graylog2 at the moment, actually, to be honest, we're replacing logstash with Graylog2. We're handling on one machine 220, I think 220 gig of syslogs that come from postfix per day, yeah? Just on one machine. If you click on one of these messages, then you get the list of fields that are contained in that message. And these fields, you can use these fields then for further selecting. You can see statistics on those fields, how many times does that word show up, or if you have numeric fields, you can see, for example, took so many milliseconds, you can see little graphs just pop up, how many milliseconds that whole thing took in average over the selected time frame. You have at the top here a menu which is available to administrators, where you can see system things. I'll show you one in a second. You can create dashboards. So if you want a dashboard, for example, which shows you and your team, you have a large screen in your office, shows you and your team how many HTTP requests are coming in, or how many code 500s are being produced, how many spam mails are being delivered in per minute, per 10 minutes, per whatever. You can very easily, literally with clicking, drag and drop, create dashboards that show that. You can do that in Kibana as well, with a bit more work, and maybe the ones in Kibana look nicer, but it's certainly, at least to my mind, it's certainly easier to do that in Graylog2. And here again, these dashboards access Graylog2 server via the API, so they are limited to what the logged in user may actually see, which is a good thing. So let's look at another screenshot. Here's part of the system page. Here at the top, there's a flashing 2. It doesn't flash here, but normally flashes. That flashing 2 means there are 2 warnings. So if you click on that, Graylog2 will show you those warnings, and you can then react on them. You see at the top right, constantly updated, how many messages per second are coming in on this machine. Okay? You see the nodes. Here we have three nodes. We have a radio, and we have two servers. Here, processing pause, so this also moves. You see how many logs are coming in, how much memory is coming in. So you have a rather good overview through Graylog2 how your whole system is handling at that moment. I think that's the last screenshot. Yeah. So these are basically the two different combinations: logstash and Kibana on the one hand, or Graylog2 with Graylog2 Web on the other hand. Both, of course, both combinations you can mix and match, and both of them use Elasticsearch as the actual search engine. And then just a few words on how to actually get logs there. I've been saying you might want to use syslog UDP port 514, but sometimes that's not possible because you're behind firewalls, etc. You need to be able to ship your logs. You need to be able to take your logs to the machines which are running either logstash and or Graylog2. And there's a gigantic number of different ways of doing that. Some I've just listed here. Syslog-ng instead of syslog-d, for example, or rsyslog, very interesting because you can format logs, okay? You can also, syslog-ng support things like Redis, support things like AMQP, so it's relatively easy to push over. Syslog-ng allows you to do syslog over TCP encrypted, which is very important sometimes. If you are in areas which require encryption of logs before they cross the cable. I think rsyslog can also encrypt, no? Can rsyslog encrypt? Thank you. Can rsyslog encrypt? Yeah? Okay. So Redis or ZeroMQ or AMQP, if you have AMQP anyway as a message queuing system, pump your logs in there, take them out on the other side. And you have the additional benefit, as I mentioned earlier, you have the additional benefit of a buffer. If one of these systems goes down, you have to restart logstash because you've modified a configuration, or you want to restart Graylog 2 for some reason or another, or you have to take the machine down for maintenance. You have a queue, you have a buffer, careful, which must be large enough, have enough disk space, you have or memory. You have a buffer which will collect your logs until your centralized logging system comes back up. Lumberjack is a utility created by, also by Jordan Cecil. He compresses logs and shoves them over via, I can't remember, ZeroMQ, I think it is. Beaver is another program similar to Lumberjack, written in Python, if you prefer Python. Yeah, so a large number of different possibilities of getting your logs from your machines, from your external mail service, from your external web service, etc., into your centralized logging system. And it's worth investing a bit of time in getting at least that bit right. That's probably one of the hardest portions. And last but not least, this has nothing very much to do with centralized logging. Any of you know Graphite? Oh, quite a few, okay. Graphite is probably the worst program to install that was ever created. But once you do get it right, it is really quite magical. And Graphite is a system to which you just pump metrics. How many of this, how many of that, how long did this take, how long did this request take, how long was my program in this module, etc. Just pump metrics in there. And with Graphite, you create, the Graphite user creates dashboards, which literally on demand and on the fly show what is happening. Very, 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 very powerful. Also different methods of getting the metrics in there, but lots of fire and forget. And if you noticed earlier, logstash, for example, has a Graphite output. So how many code 500? Just pump it into Graphite, and Graphite will be able to demonstrate it, to visualize it and show you. So, and to end, just the 3 links to these 3 products. If you're starting afresh, my recommendation would be have a look at Graylog 2 to start with. I'm not saying it's better, different concepts. But Logstash, the combination of these 3, really very, very powerful. And I think they can make one or the other of us very happy. Any questions? Do we have time for questions? 3 questions? 2 questions, okay.
Why should I use logstash when I've got Graylog?
Why should you use logstash if you have Graylog? Yeah. You shouldn't, or you shouldn't necessarily. Graylog 2 has a message parsing interface, so-called drools, which is a Java something or other, which is being improved on. So you can split up logs in Graylog 2, but you may feel more comfortable with the way Logstash does it. Grok, for example, in Logstash is tremendously powerful. And Lennart Koopman of Graylog 2 would very much like to also offer Grok in Graylog. Grok in Graylog. And that will probably happen someday, but at the moment it's not in there. So you must not use them together, but you may wish to use them together because of the filtering capabilities, which are probably more powerful, in my opinion anyway, in Logstash. So it might actually be worth your while to certainly read the documentation and check how do you want to filter and use Logstash to filter into Graylog 2. Louder, please. Louder, please. Sorry, I can't hear you. Louder. if you used logstash, you don't have to. If you use logstash together with Graylog, yes, then it would be like a preprocessor, preparser. That's the way that I would do it. I'm not saying you have to do it, okay? Graylog 2 lives fine without logstash, okay? One more question.
Is there still room for a question? I think people are...
Time over. Okay, I'm sorry.
Sorry.
Thank you very much.
Thank you very much. We'll see you later on.